Good morning and welcome. We are going to give the audience another maybe 30 seconds and then we're going to get rolling. So just hold tight and we'll start here in a minute. Welcome. My name is Rick Kutcipal. I'm a product planner in Broadcom's Data Center Solutions Group and a member of the board of directors of the SCSI Trade Association. Before we get rolling in this webinar, I'd like to go over a couple housekeeping items. For questions, please enter them in the dialog box provided. We will answer them at the end of the presentation. For any that we don't get to by the end of the session, we will be posting a Q&A blog on the STAY website with answers to all of the questions. For copies of the slides, you can download them in a PDF format from the Bright Talk website. And we're going to have a couple polling questions during the presentation to kind of keep it interactive. So at the given time, and I'll announce it, please click on the vote button and enter your response. So with that, let's get rolling. So joining me today, I have two industry analysts. I have Jeanette with TRENDFOCUS and Patrick Kennedy from ServeTheHome. Don, you want to give us a brief introduction?
Sure. Thanks for joining, everybody. Again, like you said, Jeanette from TRENDFOCUS. I've been an analyst at TRENDFOCUS for almost 9 years now. Prior to TRENDFOCUS, I started in the storage industry in the 1990s, hard drives and SSDs and controllers, tours of duty at Marvell, Fujitsu, and Toshiba. And as you know, Toshiba became Kioxia. So again, thanks for having me, and I'll turn it over to Patrick.
Awesome. Hey everyone, this is Patrick Kennedy from STH. I have the best job in the entire world because I get to show everybody all of the really fun components, whether those are servers, storage, networking gear. My team and I, we have both the STH main site as well as the YouTube channel. So if you want to learn about it, definitely go check those out. And today I'm going to show you a lot of the things that we're going to talk about.
Awesome. Thanks, Patrick. So I wanted to get us together today to talk about some of the storage trends that will be in front of us in this year, 2023, and also through the decade. You know, we really live in an exciting time with massive investments fueling, really cool innovations in storage. And Patrick's going to show us some of those. It's pretty cool. But we want to talk about, some of the advancements in the media, and also talk about, the growing demand of capacity and some of the craziness around form factors. So let's dive into it, and we'll start with media. As you know, SSDs and HDDs are very different vehicles for storage. So, what are some of the trends driving these, and what are we expecting to see in terms of both SSDs and HDDs? So, Patrick, you want to start?
Yeah. So something that we're seeing in modern servers is that, we started from years ago where we had SATA and we also had SAS. And those were really the two big interfaces that if you did storage, that's pretty much what you're going to do. And then starting about like 2012, 2013, we started to see more PCIe-based storage than NVMe storage, and really took over the PCIe bus for storage. And so now we're living in a world where SATA SSDs and hard drives, we have hard drives here, we have SATA SSDs here. These are definitely starting to become a little bit more challenging to even integrate into systems as the number of SATA ports goes down. SAS is a little bit of a different story. So we have like brand new, this is going to be in our PowerEdge R760 review. We have a brand new SAS drive, but these are still, SAS definitely still is a solution that we're seeing in new servers. We're going to see in more servers and storage arrays in the future because there's a huge ecosystem around these. But I think that a lot of the in-server storage is going to be either SAS or it's going to be PCIe. And there's a number of different form factors that we'll talk about a little bit later in terms of what those are going to be.
Perfect. Thanks. And Don, from more of an industry perspective, your take?
Sure. Yeah. I mean, it's, whenever I'm thinking of storage and protocols, I tie it to markets. Always three main buckets for markets: system OEMs, sometimes call that traditional enterprise, data center / hyperscale, and then the channel market on the third one being the smallest one. So for SSDs, like Patrick said, PCIe came out around and started making headway around 2012. But before that, SATA and SAS, you see it.
I'm listening.
You see it on the right pie chart there. It was kind of a legacy, a natural transition because of hard drives. So storage vendors did integrate with SAS. SATA, obviously a legacy protocol that was out there, but that's more of a storage OEM protocol. That's where about all of that those SAS exabytes for SSDs go. Whereas SATA, you see a good chunk of exabytes going to traditional enterprise for servers, and then also on the channel, aftermarket, and then we think about, hard drives, right? Nearline dominates the exabyte ship. This is just one quarter, right? 260 exabytes shipped in Q3. These are final numbers. The vast majority of all exabytes shipped, again, 86% was nearline hard drives, and a good 60 to 70% of those exabytes go to data center customers, the remaining to traditional enterprise or system OEMs. So again, within that nearline, it's about 75% SATA going through the connector, and about 25 or so % SAS going through the storage device connector. But let's remember, within those hard drive infrastructures, it's all a SAS infrastructure going there. So there you go.
Perfect. Thanks, Don. So talking about capacity, that's another topic that I wanted to touch on. But before we roll into that, I do want to do a poll. So the first polling question is, what percentage of enterprise / data center capacity, is driven by SAS, in your opinion? So if you can complete the poll, and then we'll review those results here in a minute. And while you're answering those, let's look at what's driving, some of these needs for the capacity, in 2023 and beyond, right? Patrick, from your perspective, what are some of the trends in system architecture that are driving the capacity growth?
Yeah, that's a really great question. And so I think we're going to bring up a slide right here. And really what I wanted to show was I just mapped out, if you bought a 2-socket server on a what's the highest core count server processor you get from either AMD or Intel, all the way back from 2010 to the recent launches that we just had a couple weeks ago. So, when you kind of look at that, what you see is that the performance or the number of cores is scaling dramatically. And so we went through a period where that really was not increasing that much, but nowadays it is definitely accelerating by a pretty huge margin. And there are two factors that a lot of folks think about. One people think about, one folks don't really think about. One is just the number of cores is dramatically increasing, and we'll see on the x86 size 128 core Bergamo from AMD this year. But the other side to it is that the performance per core has essentially doubled from the E5 V4 generation. And even if you got like the top end E5 V4 versus last year's Genoa, you're talking about more than 2x performance per core increase. And so what the impact of having more cores and having twice the performance per core is really just the fact that modern servers can handle anywhere between 8 and 9 times the number of virtual machines, containers, etc., as the machines that we had, that you would be deploying in, say, 2017, 2018, 2016, in that era. So, one of the big things that's driving storage is just the fact that the machines that we have today are so much more dense than the machines that we had previously. And so this is just a quick look at, I know a lot of folks haven't seen these yet, but on the left-hand side, we have a dual socket AMD EPYC 9004 Genoa. And that will also house Bergamo later this year in 2023. And then on the right-hand side, we have just launched on a couple days ago, which was the Intel 4th generation Intel Xeon Scalable Sapphire Rapids platform. And so, you have both of the newest generation of servers. They're still probably, if you were to order one today, a lot of folks will probably be waiting a little bit for them. But just want to show folks what these servers are. And these things are they may look very similar to what you saw 5, 6, 7 years ago, but they're a completely different class of CPU performance, memory capacity, memory bandwidth, and PCIe connectivity. And so I just wanted to kind of show that PCIe connectivity, because that ties directly to the number of SAS controllers you can have, so number of drives you can put into a system. But also, if you have PCIe drives, like NVMe drives, you just physically need PCIe lanes. And so something that has happened is we went from a period where, per socket, you'd have, say, 40 to 48, and that was, about 7 years of that. And now we're moving into an era where you went to, say, 64 to up to about 80 lanes per socket. There are some configurations where you can get 128, but that's more of a single socket thing these days. So, just the number of PCIe lanes has, started to greatly increase. If you look at that first 7 years on that chart trend versus the last 3, you can see the acceleration there. And what that's doing is that's really a response to the fact that the systems are becoming faster. And because systems are becoming faster and have more capacity, you want to have more consolidation. You physically just need more PCIe lanes to do that. The other thing, though, is that those PCIe lanes are not the same PCIe lanes that we had for those first couple of years. So we're just kind of looking at the last 10 years here. If you look from 2013 to 2020 on the Intel side, what you're going to see is that that's almost a very flat curve, because that is a PCIe Gen 3 era that lasted a very, very long time. And what I did was I said, okay, well, PCIe Gen 4 is about twice as fast as PCIe Gen 3. PCIe Gen 5 is like another doubling. So when we get to the 2023 generation, we'll call that the servers that I just showed 2 slides ago, you'll see that not only do we get more lanes, but we get more performance and more throughput per lane. And what that gives us is just a ton more PCIe capacity. And so as these servers kind of really drive for that higher consolidation, you need more PCIe bandwidth, and that's exactly what we're seeing here.
Awesome. Thanks, Patrick. Before we turn to Don and his industry view, let's look at the results of the poll. This is pretty interesting, right? So we broke it up into 4 buckets, 0 to 25, up in 25% increments. And if you look at the results, there's a huge range, right? 17% of the audience estimated that 0 to 25% was of the storage capacity is behind SAS. Getting into the center, 25% estimated 26 to 50%. The winner in the poll would be 51 to 75%, but then some also said 76 to 100%. I want to turn to Don, and I want to look at his slide. He has a slide he's going to show us, and then we're going to come back and talk. Measure up the results of this poll with some of Don's numbers. So Don,
sure. What's driving the growth that we're looking at in our forecast here? Obviously, the huge growth area is still hard drives, right? Nearline hard drives, SAS and SATA. What's a main driver for that? And the simple answer is cost, right? We're at just over a penny a gigabyte today for large volume customers for nearline hard drives. Think about that. I mean, that's compared to 7 to 10 cents for a volume SSD, right? Tape is even lower than nearline hard drives. And yes, tape is still shipping. As a reference point for last year, tape did about 80 exabytes, and it's still going, right? Enterprise SSDs, we did about 150 exabytes, so about 2x that of tape. And then enterprise hard drives, we did over 1,000 exabytes, so more than 6x that of enterprise SSD exabytes. So huge, huge number. So to stay on hard drives and talk to that growth there, 2022, your average capacity was 18 terabytes. That's going to greater than 30 terabytes in the out years. It's a known entity. There's roadmaps to support the areal density growth. Think of HAMR, think of SMR. Vendors are supporting that. There's only 3 vendors left shipping hard drives. And the hard drive industry has been at it for about 70 years. They know what they're doing. And basically, since it's all they have left, they're going to do everything in their power to maintain those technology jumps, those capacity jumps. And if it's at just over a penny a gigabyte today, you can, or I'm sorry, a penny a gig, that's going to continue to go down a little bit in the out years. So cost is going to drive that demand there. And again, 70 to 80% of that volume is going to data center. Data center markets, they don't have end markets that they're shipping to, right? They're building their own data centers. They're giving us faster load pages. They don't have to worry about swim lanes. So that's hard drives are going to still continue to do that. SSDs, what's helping drive that growth? Obviously we started out really small years ago, shipping very minimal exabytes. It was pretty darn expensive back in the day, but cost is continuing to drop. Like I just said, for enterprise, it's well less than 10 cents a gigabyte today for volume SSDs. NAND densities continue to push, right? Think of it went from SLC to MLC. TLC is the volume today. It's about 96 to 95% of the volume of all NAND that ships in the world. We're going to head to PLC here sometimes down the road. But QLC still in its infancy, still minimal volumes, but that will take off. So again, these end markets, OEMs, data center, and channel, all have different, type of business models and how they support their end customers. We'll talk more about that in the coming slide for form factors and how they're being supported for densities. Okay, thanks, Rick.
Yeah, no, thanks. And so if we can stay on this slide for a minute, what I would like to do is compare, the results of this slide to the results of our poll. And it's a little hard to get percentages off Don's slide, but if you look at 2022, you can see that well over 20%, well over 25% is nearline HDD. And remember, also you have a small performance enterprise HDD line in there, and also tape. Those would all sit behind a SAS infrastructure. So whoever voted in that top bucket of 76 to 100% of storage capacity sitting behind a SAS infrastructure, they're correct. So it's a pretty amazing number, and that's kind of what we wanted to highlight here is the importance of SAS in the modern infrastructure, whether it's enterprise or the data center. Another thing that Don talked about was the importance of hard drives and SAS in the data center. A good example that was very visible earlier this year was Meta's announcement and their OCP submission of Grand Canyon, where it's 72 SATA hard drives. So 72 6 gig SATA hard drives that all sit behind a 24 gig SAS infrastructure, of course, leveraging the latest innovations in security, as well as taking advantage of a lot of the new features in SAS and SAS 4. So I think that's pretty interesting and relevant to this conversation. All right, with that, let's switch gears. Now we're going to talk about form factor. For HDDs, I'm going to say pretty boring, right? It's 2.5 inch, 3.5 inch. Patrick's got them all right there. There's a monster, 3.5 inch, and then some of the smaller 2.5 inch. And every once in a while, there's talk of another variant of form factor, but for the most part, it's 2.5 inch and 3.5 inch. In contrast, you got SSDs, and it's kind of the Wild West because it started with 2.5 inch and M.2, right? A lot of M.2 in the client. But now we have some emerging standards, with E1 and E3, and then all the variants of those, right? So it is really the Wild West, and right, and it's all attributed to the fact that it's solid state storage. It's not rotational media, so all of a sudden a lot of those rules start changing and become more flexible. But before we get into the conversation, I wanted to do another poll, and this one's just more of a informational, because it comes from a discussion that the three of us had before this, and that is, what form factors are you planning to deploy in 2023? So if you can go ahead and click that vote button and enter your numbers there, we'll look at those results in a minute. And while you're completing that, let's look at some of the factors that are driving these changes in form factor. And then, maybe we can get each opinion, Don and Patrick's opinion on, who the winners are going to be, if you will. So Patrick, you want to start?
Yeah. So let's talk a little bit about the form factors. We talked about 3.5 inch, 2.5 inch. We have all of the different ones. Hey, can we switch back to the camera view real quick? Yeah, there we go. We'll just show these off real quick. Something that we're seeing is a big move in the, I guess, 2.5 inch form factor. We've seen some pretty interesting things happen. So, we have the Dell EMC. This is a 1.6 terabyte drive over here, and now we're seeing, larger drives like the 32 terabyte drives, which are ones that we just looked at on the STH site this week. So we are still seeing some innovation there. But one of the big challenges is really the power and cooling of those drives, especially as we get to PCIe Gen 5 and the signal integrity that you need to be able to move something from the storage array that sits at one part of the server all the way back to the processor. And so folks have been working on different connectors. They've been working on different form factors to address those. I have an older example that I think a lot of folks may have seen on this, which is the old Intel Ruler SSD, which is not EDSFF and it's not E1L, which is a big thing. But, folks were really experimenting with what are the different form factors that we can use to really kind of make servers more dense, right? Because we have all that extra PCIe bandwidth that I talked about earlier. We have more PCIe lanes. What can we do with that? And so, really good example of that, we talked about M.2, and M.2 is very well known in this client space. But also, this is the brand new Dell Boss little carrier that goes into Dell PowerEdge servers. So if you have the boot option, there's an M.2 drive on a carrier. And then what you'll see is that those were good, but one of the challenges with M.2, of course, is that it's not hot swappable, and it's not really designed for the heat dissipation that you need for the newer drives. And so what you'll see is that we have things like E1S, which is going to be a replacement for that, and a lot of effort in the market, I think, around these form factors. And E1S is part of the EDSFF, generation of drives, which is really being driven by a lot of the hyperscalers, and then a lot of the other folks in the industry have gotten behind it. And so if we can go to that slide that we flashed up, let's see if we can get that one. There we go. I call the old 2.5 inch old fashioned. The EDSFF, you'll see we actually have different heatsink heights effectively, so they're different width drives, and that is really to allow more power to be going through the drive, which allows you to therefore you need more cooling for that, and so that's why you have different thicknesses. The other one though is E3S, and you're going to see that in the background there. That E3S drive is in many ways there are different thicknesses there as well, but it's really the replacement or the next generation of 2.5 inch, and it's really designed for solid state storage. And one of the really interesting things about EDSFF is that it's not designed solely for storage, although that's going to be probably the primary application that we're going to see early on. There are a number of companies that are building E3S and also E1S accelerators, because you are assuming that you have a PCIe-based interface, and because you have a PCIe-based interface, if you make something like a AI accelerator or a crypto compression accelerator, something like that, that would be something that you can now put into a EDSFF form factor and then have a hot swappable module. The other thing that EDSFF is looking at is CXL, and folks are looking at EDSFF devices not just when they think about capacity for storage. They're not just thinking about non-volatile storage in SSDs. They're also thinking about volatile storage with CXL, and thinking about how do we do things like having memory expanders. We're not going to go back to my view, but you may have seen that we had an Astera Labs CXL memory expansion module. It's a PCIe module. It plugs in right now to a PCIe by 16 slot. But in the future, there are a number of companies working on putting memory and DRAM directly into the same form factor that you put in SSD. So it becomes a lot more flexible in the future, especially for high performance applications. So anyway, with that, maybe Don can give us some insights.
Yeah, Don.
Yeah. So when it comes to form factors and where we've come a long way, right? Even through 2021, 2021 are actuals, and then I'm forecasting through 26 is what you're looking at here. But, we mentioned earlier M.2 for client. So economies of scale were driven from that. But we learned from that from a business case, from a business perspective. M.2 and PCs, really didn't take off until obviously the pricing dropped. But even to a finer point, we think about M.2 SATA, which was the first one that migrated to M.2 PCIe. And everyone was asking every design generation every year, when will M.2 PCIe take over in the PC take over SATA? And it really didn't happen until the PC OEM companies sold their systems to their end customers with M.2 PCIe at about the same price point as a system that would have had M.2 SATA. So we had to have that like for like pricing for it to take off. So, remember that when we talk about, again, major data center customers, and then system OEM companies who have to deal with their end customers, and where we see form factors. So in 21, M.2, that was dominated by basically two companies in the world, right? It took up 20% of all the exabytes shipped. They didn't have to deal with an end customer with swim lanes and price bands. They're building their own systems. So they said, let's build a nice slim form factor system. We have M.2 gum sticks we could pop into there. And there was a lot of success found there. U.2, again, it does ship to major data center customers as well as system OEM companies, multiple regions of the world, both China and US for data center and OEMs. But, 1 to 2 companies decided to go that route, especially in data center. That drove most of that volume, almost 75% of that volume. We do see in OEMs, but again, let me talk about OEMs for a second for servers and storage. They have to maintain a roadmap. They have to maintain different price bands, right? And within those price bands, the highest performing, highest power system is usually going to be your highest price system to end customers, your traditional enterprise market. Highest price, for our business school cap, highest price usually means lowest volume, right? Lowest price usually means highest volume. So think about that. U.2 PCIe, SAS next, SATA, SSDs under that, and we're still shipping 10K hard drives, right? All those different swim lanes for those storage devices for servers out there. So now we move forward, and how do we see these transitions happening? And it's really tied to different customer segments, right? So for major data center customers, like Patrick mentioned earlier, M.2 is transitioning to E1S. Again, dominated by a couple companies. So in data center, so when they decide to transition, if they have vendor A and vendor B at their disposal, so they have like for like products, pricing is in line with what they're currently buying, they could build the systems, they transition over. It's a little faster to go from M.2 to E1S. That's why you see M.2 shrink as a percentage mix in 26 very drastically down to about 5%. And that 5% incorporates, 5.3% incorporates both system OEM business, selling to end customers, as well as major data center companies for minimal legacy support. U.2. So U.2, again, dominated by data center today and OEM business, right? So we're at about 45% of the mix in 2026. That's OEM business and some data center business. Think about the comments I just made for swim lanes and price points. And that's where E3S transitions in as a new, higher performing PCIe Gen 5, top of the line server system that Patrick highlighted some of the points earlier. So that 11.3% of E3S out of the gate, starting this year, is driven by traditional system OEM business. But again, think about it. We have to deal with design cycles, whether it's one time a year for a major system OEM to do a new design, right? So they'll add a new SKU with a new form factor, add a new higher capacity point, right? But at the same time, they still need to maintain all those other swim lanes with those other form factors, other protocols, hard drives and SSDs, right? So that's why you don't see that jump up as aggressively as you would say with a data center customer. E1L, previously not EDSFF as Patrick mentioned, but whether it's a ruler type form factor, E1L, that's a data center play, right? it's QLC technology, right? It's storage. So if a major data center company decides to, and they did decide to go that route, you will see some growth there, and obviously at a very compelling price point for that storage system. So, okay, I guess that's what I can say about that.
No, and no, that's really interesting. And one thing that you touched on, I think it's really important, is the tail of some of these technologies, especially in the traditional enterprise. Maybe not so much in the data center and with the hyperscale data center customers, but in the enterprise, the tails on these technologies are very, very long. So thanks, Don. So if we look at the poll results, what they seemed very very in line with Don's charts. So he had two different pie charts, and it pretty much echoed what Don was saying. With still M.2 still shipping a bunch, 2.5 inch still being the majority, but E3 starting to come on. So that was a very interesting poll. So with that, let's turn it to some questions. Are you guys ready for questions?
Let's do it.
All right. So I'm just I'm thumbing through a handful of them here. We have a bunch. When you say enterprise, does that include cloud service providers, or is that a separate category? So let me answer from my perspective. I think it's going to be pretty important to get everybody's take on it. When I typically say enterprise, I include the cloud service, the CSPs, the cloud service providers. I know that in some jargons they do separate them, but I guess I distinguish the enterprise and the CSPs. I distinguish them from the client. Is really my distinguishing. Is the way I do it. So Don, how about you?
Yeah, good question. So historically, at the product level, there's two buckets: enterprise or client, right? I think as things have progressed, and if you asked me that 10 years ago, I would my response on enterprise would be, does it have power loss protection? Whether it's discrete caps or super caps, it's enterprise. That has now morphed. So when someone says, is it enterprise? I could say, well, are you talking about end markets? There's traditional enterprise end market and a data center / hyperscale end market. So again, product versus markets. So enterprise for me at the device level still encompasses both of those markets. But then if they want to go further, where do those products go? It's data center / traditional enterprise market.
Patrick?
Yeah, I would say, from my perspective, I think that categorization is totally right. So when we started STH probably about 14 years ago, there was definitely client and there was enterprise. Because the cloud service providers have become such a big market in themselves, we tend to use now, like on STH when we do our coverage, we tend to actually say data center versus enterprise. And there's even some pockets of folks that operate at a smaller than hyperscale, of course, size, but operate and build infrastructure that's much more like a hyperscaler would do it versus a traditional enterprise, right? And so we kind of segment out data center and enterprise nowadays because of that. And so, but on the client side, you would also do, a lot of people on the client side would say there's a big difference between desktops and laptops, right? So, and we just saw a whole bunch of guys fall. But anyway, yeah. So that's an example of what I would say is a big difference these days.
Yeah, and another way to state it is sometimes we talk about data center class SSDs, enterprise class SSDs, and a delineating point would be level of qualification, right? Certain yield metrics coming off the lines, right? They'd be two different buckets. That's another way certain people talk about it.
Okay, perfect. Thanks. We have another one. Why are the hyperscalers still planning to use SAS for storage? So Patrick, you want to? I have some thoughts on this, but
yeah, I'll give you my easy answer to that. Right, it's just, so if you look at a piece, so this is a modern server, right? So this is a single socket Sapphire Rapids Supermicro server behind me. And when I talked about the fact that the PCIe Gen 5 lanes are so much faster than PCIe Gen 3 lanes, just the fact of the matter is that when you have a SAS controller, you can handle so many more hard drives for a given lane of PCIe bandwidth, and a hard drive can actually feed it. And a really interesting way to think about it, just conceptually, is actually that a PCIe by 16 slot, so something that this would plug into, that now has more bandwidth on a server like this than you had in an entire server in a couple years ago, right? So that's a 2017 to 2019 server, right? So just the architecture that we think of with SAS, one of the biggest reasons for it is, one, because you can just put a lot of storage behind it, and two, the fact that the dual port SAS, especially if you have if you're running like a multi-home solution where you have like dual port SAS, that's a solution that there are dual port hard drives, or dual hard port dual port NVMe drives, and some of those are here, but a dual port NVMe drive, not every drive is, even if they are considered an enterprise, not even a data center, but an enterprise drive, not all of them are actually dual port. And so, there are reasons just in terms of performance, there's reasons in terms of just that big architecture that I would say, really drive that.
Don?
Yeah, I mean, from a storage device level, SAS hard drives and SSDs, more throughput, dual port versus single port, better ECC, right? Some technical and reliability metrics that would favor SAS over SATA.
Okay, and so I do have some thoughts on this, and I think when I first read the question, the first thing that came to mind was scalability. Right, the scale of some of these machines are absolutely enormous, right? And it's about their nearline capacity, right? It's saving everybody's pictures on Facebook. It's saving TikTok videos at ByteDance, whatever, right? It's about nearline storage and the scale of it, first of all. And the second one is the dollars per gigabyte. How are you going to store all this stuff? I mean, think of the amount of capacity that has to be in a hyperscale data center. It's absolutely enormous. And if they have to pay $1 more, I don't know some of the numbers, but pick a data center and let's say they buy 10 million drives a year. If they're paying $1 a drive more, that's $10 million off their bottom line, right? So these numbers are absolutely huge. So $1 per gigabyte is a huge metric. And Don touched on it earlier. His metric was a little different. What it was, cents per gigabyte, I think.
Penny per gig. Yep.
Yeah, penny per gig. Right. And what you said, penny per gig for SATA drives. For nearline.
Yep. And then sub 10 per SSD.
Sub 10. Yep. Okay. Yeah. So I mean,
and think of it this way. Another thing is supporting these storage requirements from a production perspective. The entire NAND industry would do currently, call it 170 exabytes on a given quarter. You have to take care of every PC out there. You have to take care of all these enterprise SSDs that we're talking about now. You have to take care of every smartphone in the world, which consumes about 33 to 35% of the NAND every quarter. And then all those other applications, DIY, embedded, spot market stuff. It has to get spread around. Nearline in the quarter we just talked about did 255 exabytes alone, right? So think of the production support. So even if the NAND industry, maintains at a 25% CAGR for supply in the long term, you're still not coming anywhere near enough of what it would take to displace all those the SAS hard drives that are out there today.
Right. Yeah. Good point. Right. Let's try another one. Do your numbers for SAS include both HDD and SSD? So Don, I think that one is targeted specifically to you.
Yeah. So of the hard drive number I threw out of the 255 exabytes, again, it's about a 75-25 split in favor of SATA. Of the enterprise SSDs, we're doing about 5 exabytes a quarter SATA. We're doing about 3 to 4 exabytes a quarter on SAS, and then the bulk of it is PCIe, a good chunk of it, 24 to 26 exabytes.
Okay. And another one, the next question, I'm going to kind of couple in with that. How do the numbers of units compare to exabytes shipped? It's a good question.
Yeah. So for hard drives, the sweet spot for nearline SATA or SAS, it's about 18 terabytes today. So the numbers are obviously lower. For SSDs, we've been running at a terabyte for SATA for a number of years now. SAS, we're averaging about 3.6 to 3.9 terabytes today. And PCIe, interestingly enough, is lower than SAS today. But with these new form factors that we keep talking about, that average cap for PCIe is going to really, really pop up because of the data center implementations with E1S, 1 terabytes going to 2, 4, and 8. Ruler E1L, 16 today, going to 32. U.2 today, average capacity is about 6 terabyte. That's going to 8 and then 16 down the road. So that's why we always look at exabytes, because that's where pretty much every vendor and customers, looking at what they're going to buy, how much storage. As the capacities go up, the units kind of flatten out in the forecast. You actually could have a potential dip in late 24 to early 25 on units, because you got some big migrations going to new form factors where it's going to be 4x in some cases, 4 1 terabytes go to 1 4 terabyte. So
interesting. Okay. All right. I have another one, and this we might have already answered, but let me put it out there. What is the cost difference between HDD versus SSD, and do you see the cost parity getting closer? So Patrick, you want to?
I think it's definitely Don's.
That's
okay. All right.
Yeah, again, we're at $1+ a gigabyte nearline today. It's not going to go down 30 or 40% a quarter or a year, depending on supply, like we're seeing in NAND today, right? You can go down, 40% in 2 quarters on NAND or SSD, but it might jump back up another 20 or 30%, depending on which way the wind blows. But it will continue to go down, right? So for SSDs, if we're at sub 10 cents a gigabyte today on average, plus or minus, it's going to go down even with QLC implementations in certain spots. But my answer to, same price is probably never. I think, a lot of us will be retired years out if and when that happens. But even if it gets cut by half, right? 1 penny to 4 or 5 cents a gig. It's going to be tough for a lot of teams out there, customers out there, to look at that and say, let's do it. I know a lot of times product specifications win on paper when it comes to comparisons. We talk about, total cost of ownership in certain areas. But at the device brick level, you ask any procurement team at any company in the world, and it would have to be nearly the same price to transition over from one technology to the other. Okay.
Yeah, that's really good. Another thing I think that we need to keep in mind is that so you talked a lot about what's going on the SSD side, on the NAND side, driving the cost down, and that is definitely happening. But at the same time, we got to remember that, the 3 remaining HDD vendors are still investing very heavily in, capacity optimized technologies, right? We've seen incremental improvements, with things like SMR. And, on the horizon, we're watching HAMR. And, when HAMR happens, right, that could be, a real boost, on the HDD side. So, very active playing field there.
Yeah. 3 metrics, Rick, right? HAMR, SMR, and we're still adding components, right? Remember, it seems like yesterday we were shipping nearline hard drives at 4 or 5 platters. We're at 9 or 10. There's, discussions
11.
going to 11, right? It's right there, right? So they always find a way, and I'll end this comment with, for the 3 vendors left, it's all they have. So they're going to do everything in their power to keep that competitive edge, to get that 1 penny down even lower. And then you start talking other business metrics. What are the margins, and can they tweak down the margin even more and just elongate that life cycle?
Right. And, another thing that, and this is you may be getting a little bit away from the topic, but as these capacities of these drives increase, right, it brings along a whole new set of challenges for them, and they are being addressed, right? You look at the IOPS per terabyte problem, right, being, addressed with dual actuator. you know, depop with all these platters, right? Logical depop of the platters, right? Or media in itself, you know, things like that. So it's not as simple as just saying, oh, they got to, improve capacity and they can do it with hammer or whatever, right? But then there's all sorts of other problems that come along with that. So it's a very interesting landscape.
Yeah, and then some of the mentality out there for a lot of these customers, whereas 10, 20 years ago, it was, you need to give me the best possible performing, 5 nines reliability of any product you ship me. And if there's a problem, we got to go 5 months regression testing and give you 3 binders as a report and make sure it never happens again. Today, and for quite a number of years now, especially for SSDs, and that's why it helped it take off for a number of years, is the mentality of what's good enough, right? So best you can possibly build before, what's good enough today, and I have enough to replace it if something goes wrong. That's kind of how things have changed.
Interesting. Okay. All right. We have another one. What is the future for U.3? And they reference, of course, the SFF TA 1001 spec. And was that included in your U.2 numbers?
Yeah, U.2 should be U.X, I guess, in that pie chart.
2.5 inch.
2.5 inch.
Mm-hmm.
There are some shipments out there today. Some customers are taking it. It'll grow. But I think, all the efforts and priorities are really E3S, E1S, and then to some extent, keep E1L going.
Mm-hmm. There you go.
Okay.
Yep. I got another one. What needs to be true for SSDs to make significant gains in the HDD share?
10 and 15K are pretty much dead already. It already cut into that. And I think we've said a lot already on SSDs going into nearline. They will shave off, and you have some companies out there, storage array companies, really giving it the effort to try to sell their solid state storage systems and try to cut into that nearline hard drive markets. But we always look at it as, they're gonna shave off a little bit off that top layer of high capacity nearline based systems,
Mm-hmm.
The ones that are still priced higher, where they could start to get to a delta in a price point differential where you might see some elasticity of certain customers moving over. But to a major extent, to any hockey stick effect on a transition, especially through the forecast period we're talking about on this call, it's not going to happen. So,
okay.
Can I jump in real quick?
Mm-hmm.
I think that one of the things that you've seen, and we've talked about the 10K, 15K hard drives have really struggled because folks realize that SSDs are faster. But there are other things, like for example, boot drives, right? Boot drives used to be hard drives when we started doing reviews on STH. Now they're M.2 drives, like this, Boss card as an example. So that's taken like an entire thing where we never see. We have not seen in probably 7-8 years at least a server come to us for review that had a boot drive that was a hard drive. And you look at some of the applications that are even beyond just the traditional data centers. And a really good example of that is doing video analytics at the edge. And so there are a lot of folks that are building systems now, and they're currently hard drive based systems. They'll deploy them at the edge. They'll ingest data, put it onto an array of hard drives. And then, they'll usually have AI acceleration for inference and be able to do, inference on those video feeds live at the box, and then any anomalies go and push that up to the cloud. And, those boxes right now are all hard drive based, or almost all hard drive based. And what you'll see, I think, and what I've been hearing is that as the SSD capacities grow, so there are companies out there that look at things like, if you have a edge box and you have a box that's on every street corner, every retail location, all that kind of stuff, rolling a truck to go and fix a broken hard drive in that kind of application is difficult. There's power, there's size constraints. And so adding things like SSDs, especially as they start to eclipse hard drives in capacity, gives a new type of application that folks can go after, not just the high performance segment, but also high capacity in a more compact space.
Interesting. Okay, good discussion. I got another one, Don. I think this is for you. How do your numbers of units compare to exabytes shipped?
Yeah, I think we just let me let me give you some reference points here. So, of the 39 exabytes we kept talking about in some of these slides for the quarter when I was breaking down each technology, units for SATA was 6 million, SAS were just 1 million, PCIe was 9. So, again, PCIe 9 times 4, 36 to 40 million units in a given year and continuing to grow. So again, total units are 16 million for one quarter versus 39 exabytes. So more than 2x on the exabytes versus units.
Okay. All right. Thanks. And then, let's do two more and we'll wrap it up. The next one, it's easy. Will the slides be available? And yes, they will be available. They should be available on a link, on a Bright Talk link. If you have trouble finding that, we can have pointers on the SCSI Trade Association website. I can say that. So, but yes, they are available in a PDF form. And then finally, what do you think will be the biggest storage challenge of 2023? So I'll look, Patrick, I'll let you take a swing at that.
I was just thinking about what I'd say for that. So I think that the biggest storage challenge for 2023 is, just in my perspective, we do a lot of server research. So that's definitely, coming from that perspective. I just fundamentally think that the newest generation of servers, the consolidation ratios and just this like a hockey stick in terms of, people were used to getting maybe generation on generation, maybe like one and a half previous gen servers to a current gen server. And now we're talking like 2, 3, 4x, you're at 4 to 1, and so the idea of how do you balance and how do you rethink your storage architecture, I think is a real challenge for folks, not just in the servers themselves, but like a 400 gig NIC gives you the ability to have an entire 2017 generation, servers worth of PCIe bandwidth over a NIC, right? And what does that do for an architecture, and how do you build with that? So just for me, I think that's probably my biggest storage challenge, but I'm sure you guys have some fun ones as well.
Don?
Two things, one technical, one business. PCIe Gen 5 is obviously the hot topic today. And I hear expectations from certain companies on how it's going to go, but my response is always, it never goes the way you plan. It's going to get pushed out and a good percentage lower than the volumes you think you're going to do. And number two, on the business case, my concern for 2023 is the health of various companies out there because of the current environment we're in and what some of these storage devices are being sold at. So that's a legitimate concern on, what's the landscape today in January of 2023 versus what are we talking about in December of 2023? Because we've had 3 quarters of very, very tough times, and we have multiple quarters ahead. It's going to be interesting how certain companies navigate these waters.
Okay. Thanks. And, I'll take a swing at it, and I break mine up into 2 pieces. One, and this is coming from an infrastructure play. And, that's what I'm very focused on. And one is meeting the demands of the scale required by our data center customers, right? How do we provide that scale? And it's more than just, how many things can we hook up? It's, making them all work well together. Providing the appropriate quality of service, spin up of large systems. I mean, it's very complicated. And then the second one is signal integrity around PCI Gen 5, right? That's from an infrastructure perspective. That's a big challenge that the whole ecosystem's facing, and that's going to be a very focused effort in 2023. And with that, I'll wrap it up. We still have a handful more questions. We will answer we'll answer all of them again in our blog post, and that will be available on the SCSI Trade Association website. So thanks, you guys. I think this has been a really good discussion. Hopefully today everybody has taken a little bit away and learned a little bit about some of the different trends in media. The relevance of HDDs and the SAS infrastructure and hyperscale architectures, and then some of the trends around form factors. And you can see there are quite a few. And so hopefully, whether you're an end user, a system architect, or just interested in storage technology, I hope this helps you in your planning your storage needs for 2023 and beyond. So again, thank you for attending today's session, and I encourage you to check out our website at www.scuzita.org and follow us on your favorite social media platform. Thanks, you guys.
Thank you.
Bye.
Thanks, everybody.